Hello, today we are going to be building an algorithmic trading model. We will build the model to run on a logic that analyzes Japanese candlesticks. It will do that via neural networks, and we'll take a step further to test the model in the live market environment and see how it performs. And or basically simulate a live trading to get the feel that quants get when their models are being used or deployed. And then we will definitely make these trades over API, and we would be using the interactive brokers API today. So for sake of simplicity, I broke this project down into three stages, like we can see on the flow chart here. The first stage does the data collection for us. So what this basically does is we're choosing to collect data from IBKR over their API. And there are many brokers out there you could get data from. There's the Bloomberg terminal, there's the Alpha Vantage, there's many of them out there. But I'm choosing to use IBKR API for this project. I use it for my data collection, and I also use it for my live trade execution. And the live trade will be executed. To note, we're not going to be using real money, but we'll be trading in the live market and live environment. But we're not going to be using real money. It's going to be simulated trading. So one of the perks of the TWS API from IBKR is it gives us a paper trading account where we can make trades with live market environment and in live market conditions, but we won't be charged. We will be given a paper account with funds that are not real, that basically don't exist, just for us to test out our model and see how it performs. So we'll be doing that there. And let's dive right in. So I start by talking about IBKR API. This API is particularly interesting because of its form and how you use it. It's not just a typical API endpoint that will do res.get. So it's we have to download. First of all, we have to start by downloading the TWS API. TWS stands for Trader Workstation. It's one of the IBKR tools. We download the API. Then after that, we download the app. Rather, we download the TWS app, Trader Workstation app, on our local machine. Then we go ahead to get the TWI API documentation. We need to read the documentation because it basically gives us details for almost everything we'll be doing in this next phase. So for this phase of the project, I'm going to be going through the data collection first before I jump to the deep learning model and live trading execution. I would highlight every milestone, each of these 3 points, when we've started each one of them and when we've completed each one of them as we go on in the project. So for the data collection, we would need this TWS API documentations. It's so simple and easy to understand, to be honest, and a lot of what I'll be doing in these data collection phases will basically be copy and paste from the TWS API documentations I have here. So yeah, at this phase you don't need to know it too much. You don't need to push it, because if you try to like cram it, when another time when you need it, you would API documentation might have changed. You still need to come back here and look at how they tell you to call their API and how to use it. So yeah, that's what we'll be doing now. So I'm starting with a fresh new notebook, and always let me put my kernel restart. This is restarting, sorry. So I start with the markdown. This is data collection. So we would need to do a pip install to install the main package. We would be using the API. It's called IBAPI pip install. Yeah, so I already have it, so that's why I'm seeing requirement already satisfied. Then the next thing is to make write some import statements. So we'll do that from data. So I recently downloaded this Copilot for GitHub, I tried it. I downloaded it yesterday, and it's been cool. So I recommend you download it. So it makes your work faster and easier, and you don't have to start. Like this API now, the documentation is publicly available. So I'm sure. I don't know how this thing understands it, but it's a publicly available documentation that follows the same process. So I'm just basically copying and pasting. So yeah. So I defined my first class, which is the IB. I defined my first class, which is the IB wrapper, the E wrapper. So in step two, so what I want to do is I want this to be able to call data across a particular duration of time if we want to train it. So you could train it with the data we've had from say January the 1st this year to today's date, or whatever duration or amount of data you would need. So that's why I'm giving it a start and end date. But end time for now. We'll still give it a start and much later function. So So here we're going to be using gold, and so our security type is going to be commodity. We're going to be using gold, the commodity gold. So according to IBKR API current documentations, it might change later. This is how you call the security type. GTY. Then yeah, I wanted on smart exchange USD. Yeah. And then yeah. So in our use case here, the IBKR API we're using is the free one, is unsubscribed. So we have rate limit challenge. There's a certain amount of bars of data we can call at a time with the API. So I think for 1 minute time frame, which will give us more data and more bars, we can call more than a week's worth of data. So if I want to say this project, I want to train it across data for like 3 months. So here I would use data from January till now, or yeah, I'll just say the first 3 months of the year. Give me January, February, and March data on gold commodity every day. So in that case, I can only get 1 week, and for 3 months, I would need about 12 weeks. So rate limit issues or challenges would not allow me get that on the free version of the API that I'm using. So for that, I'm going to fetch it in chunks so that would iterate over them. So okay, get each week's what, get each week's one, and keep running on the loop. Then get the one for this week, get to save it, get the one for the following week, save it next week, get the one for then we'll now clean the overall data. I think that's the way I'm dealing with the rate limits challenges on the free version of the API. Yeah. But interestingly, if I was working with data for higher time frames, I might not really bother so much. Like if I'm working with the daily time frame data, or the daily time frame data that accounts for a candlestick being 1 day's market activity. Yeah, if I want to take data for even the whole year, maybe I would still not cross the API rate limit threshold. So yeah, let's continue. Just what noting down. So as I go in my fetching in chunks or batches. No, don't worry, we'll be good. So sometimes you need to look at this thing and be intentional about what you need from it and what you don't need from it. It's over suggesting. Yeah. So first lead with the assumption that current end date, the rest of the end dates call them separately. One can hold data and one can use the data. So when we want to run this is what we will call, that's taking into account most of the major functions right from step 1. You can see even this function in step 4 is being called in a separate portion bit here, and it's taking things from itself. So like here, our create function from step 3 is being referenced in step 4. So when we want to get the data, this is basically what we'll be needing, what we'll be calling the most. So yes, so in this place now, calling, let's call the data, call the function to fetch the data. Yeah, so the function is def this, this. Then so the function is going to take in symbol, start date, end date, bar size. So symbol, I want to take gold is XAU USD. Then start date, I need start date. Then I need end date. My start date is January this year. 01. Oh, what's the format for that date? It should be 2025 0101. For the end date to take the same structure. It will be 2025 03/28. Not safe to say. Hey, Copilot be doing wonders. Guys, I highly suggest you use Copilot too. Yeah, so if we call this now, it won't work. It won't work because of one thing. The API needs us to make reference to the TWS application. You need to download the application um on your laptop first before you get the API. So this is the application here. For this trading, I am doing a paper trading, but if I was doing in real world execution if I was doing it with real world money, I'll go to live trading and have to fund my account and all that. But I don't even have a live trading account, and that's because so it's a paper trading and I can have for now. But it works. So what you want to do is check your balance. Me, I use it to play a lot. So check your balance. You can define how much your balance is coming as, and it's basically paper trading. You can put some money in it if you play around the settings, and you can see how your balance is, blow up your account, put more money, and just continue to play with your models. But for this sake, to connect to the API quickly, we'll come to global configuration, then we'll come to the API settings, then we'll go to settings. We want to see here that this is a socket port. For demo trading or paper trading, this is the port number. For live trading, it will be a different port number, but since we are not even trading, it doesn't really matter for us. But then this is what we really want to see, and that's it in the API. And I'll show you where we call this in our code. This is our code. There's a place we call the socket port number. We need it. This is socket port number. Just be sure that everything is the same. 7497. I have it as 7497 here. I think the one for live trading 7496 or something. I'm not so sure. I've come across that before. So since it's open now, I can now run it. If it wasn't open, it won't run. I would run into errors with the API. So shift enter, and let's see while that is running. Oh, okay. Oh, there's something about my date time. Okay, I think what I was supposed to do was I should have put something that converts the data type to match this. Okay, that's very minor. I'll do that. Okay, so it's looping through to get the data because we are fetching it in the chunks of what we can get. So at every point, because of how I organize the code, it's disconnecting and reconnecting itself on the same client ID to the API. So it gets it, disconnects, and it gets it again, disconnects, so that we don't have the rate limits clash. But it's currently on 38 seconds, so I'll just pause it and do other things. Then I'll come back to you when it's done. So we're back, and our loop has finished running, and we've gotten the 1 minute data from this date, 1st of January to the last day of February. And yeah, it ran in 2 minutes. So let's see it. We converted it to a data frame. Let's see what it looks like. Data 1 minute. Good. Yeah, so we'll go ahead to clean the data. And let me do that here. I noticed they're starting from 56,000, but in total I have 11,280 rows. So I need to adjust this ordering, and then I feel like this is due to how we got the data from the API in chunks. So we need to do a bit of cleaning to get it and see that it is in the right order. So here I will start with this, the ordering, and then yeah. So first of all, what I would do is create a new column called date only, which I use to filter it by date, because the date carries the timestamp of each one. So I use that to get the right order of each one. So what we can do now is, since we have this, we can drop this date only column. We just use the date only column here to be able to get this reindexing right and not lose main data. So what we can do is data 1 minute dot drop, and drop that. Yeah, now we see that that is done, and then now we have our dates back the way we want it, and the other row is not there anymore. So yeah, the date only row is not there anymore, so that works. So now what we want to do is, let's look at our data with a simple visualization. I want to open a new cell. Okay, I can tell. Okay, let's use a visualization to see our data, what it looks like and where it is trending towards. So we'll say we use matplotlib import matplot. Does this thing know that's what I want? Oh, I'm thinking of something. Instead of calling this data 1 minute direct, so that we don't play with the data frame. We don't ruin the data frame. Let's have it say somewhere in case we mess up our data. We can always come back to call it. Let's say data underscore. What I want us to do is look at what our data looks like, where the market is trending upwards or downwards, the direction. So I'll come and quickly say, okay, first of all, I want us to preserve this variable and not ruin it. I'll save this to a new variable so that we can always get our data frame anytime we want it. Data underscore 1 minute should be called df1. Yeah. Or no, df1 should be called data underscore 1 minute. df1 data underscore 1 minute, then say df1. Yeah, so it looks good. Then make some matplotlibs. Show me coding again. I'm back. Okay, from import matplot, import byplot plt. Yeah, give me fixed size of 12 to 6. Yeah, give me this. Makes sense. Give me title. Okay, give me x label, give me y label. So we're just using only the close prices now. Okay. Now we've collected our data. This brings us to the end of our data collection phase, and which is here. So we are done with this. We already have our data, and this is what it looks like standing upward, and our data is saved to this. Going forward, beyond data collection, this is what we'll be calling in the rest of the project. So this has been knocked out. Like I said, I was going to let us know when we knock it right now. We've collected our data in data frame and we've cleaned it. It looks ready to go now. We're going to build and train a deep learning model from here. Okay, so from this first stage, I'll explain what we'll be doing briefly before we go down. Now, this is from this point onward, we want to understand each row of the data, know what candlestick pattern it contains, and classify each of these and code each of these candlesticks to their required or to their required patterns or the patterns they seem to form or bear. Then we would now map upward patterns to a downward patterns to a number. So that would help us to make trade decisions, if to buy or sell, knowing where we are going to. So we are going to basically do 3 classifications in all. It is going to tell us when to buy, when to sell, or when to hold. So it's just 3 categories we'll be using. So then definitely we're going to be using a softmax classification for multi-class classification. So yeah, we're going to be classifying them among 3 classes, but we'll be detecting over 8 candlestick patterns. Then we'll make 4 candlestick patterns that show upward reversals, 4 candlestick patterns that show downward reversals, then 1 candlestick pattern for unidentified patterns, because there are many patterns. We won't consider all patterns, but patterns we don't consider or identify in the simplest form here will be represented as 0 or flat. It means when the market is going in that direction overall, don't do anything, just stay out of the market. And if you're currently on any trade, just exit and stay out. So that's what we are going to be doing for here. So I'll quickly just run through, because of time, codes that help us mathematically classify patterns. We know a bullish pattern is something that is going up. To know what is bullish, we can just use our, not even the wicks of the candle, we can use the close and the open. If the close is greater than the if the open is greater than the close, we know we're heading for a long pattern, for a long position, and it's going to be a bullish pattern. If the close is more than the open, we know we are going for a short position, which is a bearish pattern. Just mathematically representing them to find patterns like bullish engulfing and all those reversal patterns. But I'll do that quickly so that we can run through our neural networks quickly, train the model, deploy it, and voila, we're good. And low price is equals to. So we can just, for simplicity, ask ChatGPT to give us each of these mathematical components for each price, the formula for long, short, being close, greater than this, or whatever. We can do that to be very fast. I mean, I'll do a bit and I'll pause and just quickly finish it up. So I'm using low price double equals to previous low and lowest price greater than previous close. No. Close price greater than open price, yeah. And low price is, so this would be this would be like choose a button. So I'm just going to give AI the 4 patterns I want for upwards and the 4 patterns for downward, and ask it to give me like mathematical formula similar to this for each of them, and I'll paste it here to save us time. So yeah, I'm using tweezer top and tweezer bottoms for up and down, then piercing line, bullish engulfing and bearish engulfing for up and downs. Then I'm also using hammer and shooting star, handyman, and where I don't have any of this, where it has any of the patterns that I didn't use here, just call it a no pattern for now, because I want to either buy, sell, or hold. So in those cases I'll hold, because I'm not doing so much today and I'm not training the model to do those. So we go forward from here. It's placed that to our data, then we'll print our data and see what it looks like. So I call df1 into patterns, new pattern, and I say it is equals to take from these 2 patterns, and I run this. Question report, because I'll know that when I finish. I'll do that when I'm done. Instead of importing, we're going to use Gramian Angular Fields. We're going to encode our time series into images. So all this time of this 4-dimensional, this time we have as open, high, low, and close. We're going to turn them to images and use this as the label of the images for our supervised learning for the CNN model. So let's go. Try to be very fast now, because I don't want the video to be too long. So I start from here. I'll say encode time series images. Then let's see. Encode Let's leave it as features. So yeah, we usually differentiate we usually divide to feature. We have features and target data. We divide our data into features and targets. Features are the things we want to use to predict. Target is the outcome we're targeting to predict, where we're trying to predict. So features are use everything in this data to predict this. So I'm basically using all this to predict my pattern. Where do I have pattern? Yes, where I have pattern. So I'm using date, open, high, low, close. I'm using these four things as data to predict this. So this is my target. Pattern is my target, and this is my feature. So it's a very important part of machine learning and neural networks for people to understand feature engineering, how to decide which of the data points to include in the model training. So because we want to be careful not to train with include things that are not relevant, and it confuses the model rather than learn and get better performance. You want to reduce it. You want to train it on only the important things, and at the same time you don't want to train it on just two little things. So you want it to be like the best of the best, but it's not compulsory you use everything you have on your data set, depending on the context around what you are doing. So here, this is my simple feature engineering. Then these are the features I would have in my data. Data frame object is not callable. Okay, I think is it df1 I turned it to? What did I turn it to here? What was the last place I called it? No, it's df now. Df1 now. Yes, now it should still be df1. What was the last place I called it? So features is equals to df1. So yeah, the trick here is it encodes each number, the disparity between each numbers, it encodes them as into colors. So you can read more about Gramian Angular Fields, but it's one of the most reliable time series encoding methods that we have there, and good that it encodes them time series into images, where we can train the images on convolutional neural networks, CNN. Yes, so this is how we have it, and this is just sample of some of the images that we have in the folder where we have all the images that we've converted from the entire data. So this is one row of data, another row of data, another row of data. We randomly picked one image from the Hammer class, from the Hammer folders, which is the Hammer class, Tweezer bottom folders, which is the Tweezer class, and all that. So it just populated 8 random ones for us. And the next thing is, so yeah, it'll be worth knowing about this technique called class weights. So in machine learning, many a times you find that sometimes your data, you don't find it balanced across all classes. For example, I might have 1000 images there, I might have 500 images there, I might have 200 images in bullish engulfing, I might have 3000 images in Twizzler top, I might have only 50 images in shooting star. That is an imbalance in data, and we're not going to treat all the data equally because it's going to be partial to the ones who have more images than the other. So here's where we have some of the techniques we use to combat imbalance, things like smooth, things like class weight, which is the one I'm going to be applying. We'll just address it briefly, but there's nothing like having a daily balance data. And because we are going to be using imbalance of data, I would not like to evaluate my final model metrics based on accuracy. I'm going to use other things like precision, recall, F1, which is the harmonic between precision and recall, because I know precision will favor whatever favors where we have more false positives, and the other one favors false negative. I think precision favors more false positive, and recall favors more false negatives. So false positives are like things like imagine you go see a doctor now as a patient and they tell you you have something, meanwhile you don't have it. That's like false positive, but if it's the other way around, it could be false negative. So yeah, to combat that, we use class weight. So for class weight, you need to have this dependency, import this. The next thing you would do is then let's prepare the class weight. But while we have this, before we do that, let's quickly do our train test split. So I just keep this here. I'll come back for it. I'll keep it as a comment. Let's do our train test split. What's the time? 52. Okay, so give it some time. Let's say trade. Then to save time, the next thing we'd be doing is we should actually plot we should plot like a pie chart or a bar graph of the difference between this distribution. I'll do that. 1 second, let me quickly check on what's on the chart. Yeah, so to quickly do that, we'll use matplotlib again. So let's define pattern counts. Let's count of our patterns. Pattern underscore count. Let's put our data frame 1, and then we save, give us pattern, and then count values. Then let's plot our thing here. Now Control Z, plot. Yeah, then let's say PLT the figure. PLT the figure, yeah. Fig size. Give me, let's say 8 by 8. Pages. Text, auto text, pie chart, yeah, pattern counts. Let's see if this works. PLT this. Let's see if it works. It doesn't work. Yeah. I didn't close this one. It's supposed to be twice here. So it should be 8 by 8 here. See if the AI could work. It did work. It's messed up because of this labeling, but we can see some classes are more than the other ones. So I won't bother about the labeling too much so that we don't go beyond time. This 1 hour 40 minutes already. I would just go straight to the next thing, which is the next major thing we'll be doing here is our convolutional neural network. We'll be training our CNNs, and then we'll quickly compute the class weights. Then hold on a minute, let me check on my chart. Yeah, chart is not too bad. The chart is looking okay. So I kept this for the class weight here. I would come and take it from here. Then I'll come back here and I'll put it, just call it as an import. Then the next thing I'll do is I'll compute the class weight. I'll say yTrain underscore one dimension, give it a variable. It's equals to entry domain. I just want to take my train and the axis here. Then class weight, complete class weight. I want a balanced class weight. I want a unique based on my yTrain ID. My one to my y is equals to yTrain ID. Let's give it classes. Yeah. Then I can say class with dictionary. Let's say class with dictionaries. Print it out. So here what it sort of does is, from this class take a ratio of this to this ratio from this class to this ratio from this class to be able to see that it balances the ones that extremely severely over outweigh the others, and that's what it does. But for here we'll go on to our CNN model, which is the very exciting next phase. So here basically we've done our preprocessing, we've preprocessed our data. The next big thing for us to do here is our CNN models. So I'll call it my convolutional neural network models, CNN model. Then yeah, so I'll start by calling my CNN model as a function. Then I can call it train CNN. That's how I like to default. Train CNN. Yeah, I'll pass in my train data, obviously. I'll pass in my training data. I'll pass in my validation data. I'll pass in my class names. What do I want to pass here? Pass in my class weight dictionary. You see how we apply the class weights. And then I'll close this function here, and I'll use this. Oh my god, what did I do? Okay, I entered. I took the suggestion. Okay, let's take AI suggestion over our model for us. AI gives us something very good, very simple. Take model the history. God, it's good though. It even evaluates at the test set. Okay, let's see how it does that. Print that. Save the model. Load the model. AI is really doing this. Writing my code. So this was the thing I recently downloaded yesterday. It's like his GitHub Copilot. I've never used it before now, so it's interesting to see how it's going. But what I want to also see that is put here is a way to include the plot that shows the loss per epoch and the accuracy per epoch, so that we can evaluate how our model is performing, if it's overfitting or underfitting. 1 second while I check the chat. I'll be right back. So the chat is not doing too bad. So I was going to include a plot that gives us the plot of our loss per epoch and accuracy per epoch, so that we can use to sort of see how our model is doing, and if it is, yeah, you can see the difference between the bias and variance, and then basically if it overfits. So we'll quickly say PLT the figure. I wanted to use early stopping and model checkpoint. It's using it for me. It's not using model checkpoint. It's just using model.save for me, and it's not using early stopping. But for the sake of this video, I'll just go with them like that. In consecutive videos about neural networks, I would I'll go more into details, because the aim of this video is to make algorithmic trading model, and we are nearly 2 hours into it. And so I would just leave it at that, make it very simple, and I'll come back to this. Let me watch the charts quickly. Chat is not looking too good, so yeah, so I'll come back to that. Here I want to return model. I don't want to return history ideally, so here I want to So I think this is the point where AI can assist us to, his code stops running, I just take it out and trade and define my model myself. Yeah. So this is what I'll do. Thank you for coming. Something I think I missed out was importing the dependencies for CNN model. I would have thought that I'd imported them somewhere earlier, but I can't seem to find them. That means I hadn't done them. So let me quickly import some of the dependencies I need for the CNN model. So I'd say from tensor flow.keras import layers, import models, I think I've done this before, so I should get sequential now. Oh, I think I might have spotted where the error came from. So if we look up here, we are supposed to be making validation 20% of the train set, which is already majority here. Here we divided the train to 80 and test was 20. So from that 80, we're supposed to take validation. That's a mistake with TDA. X test is small, and we are also, it should be train. And then this should be train as well. Yeah, that works. So it was the stratified thing. Then if that worked, let's see how that performs here. if that solves our main problem. It doesn't seem to solve the number of classes where it's not associated with a value. Okay. I know this is supposed to be length. I think this is supposed to be length of class names. Length of class names. We will start by defining a function that would help us do that. Say define, call this prepared data, and I want it to have my output directory. It should have my test size. Would use all these things in the function as we go on. Test size to 20%. No, I don't want all this. Test size 0.2 20%. Then we'll do validation. Validation size will be 25% of our training set. So it's not 25% of the main data, it's just 25% of our training set. So 0.25, which will be applied to just the training after it's been separated from the test. Then so next here I'll say full data is equals to TensorFlow or keras the pre-processing the image dataset from directory. And then this is what I'll do next. Output directory. Passing my output directory. Passing my image size. I actually want my image to be 32 by 32. My batch size can be 32. That's all right. I don't want to shuffle because I have time series data. Yeah, do shuffle time series. Then I'll say label mode should be integer. For image. No, let me define my images and then labels into empty arrays. Images would be an empty array. Labels would be an empty array too, so that when I extract the images and labels, I'll be able to put them in an empty array. Oh, I like this autocomplete. For images, batch labels, and full data. Yeah, these images are exactly what I would have done. The concat images. Okay, yeah, I'll use numpy to concatenate it though. Yeah, let's do that. I'll use np.concatenate. I give him my images, I give him my axis, want all but patterns to show up. So this is how this the drop pattern axis is equals to 0. So before I run that cell, I'll quickly explain what I mean. So if I run my df1, I have this, but I want to train my data with all this 4 to predict this last one pattern. So I'm going to exempt this from what my training set would see and add what it's taking as features, and this is the only thing it would see. I keep this one separate. This is target variable, it's going to be the output. So yeah, let me go ahead to so it has all our 9 classes inside, 4 bullish reversal classes, 4 bearish reversal classes, and 1 neutral class, which is our neutral class. So what Gramian Angular Fields GAF does is that it transforms time series, it encodes time series data into images from sequential time series, which is in numbers. It encodes them into images by using color codes to represent them and the relationship between one number to the other. What this simply does for us in the finance space and for the quants is it helps us to use models that are very good for identifying, for making spatial recognition and identifying spatial properties, like the convolutional neural network that are very good with images. It helps us to be able to adapt those image powers to do this. Imagine running this and using transfer learning, but transfer learning is big models that have been trained on big data sets that have been used to win award. You transfer the weights of them to learn, and it learns properly. It gives you very good evaluation, very good performance, but some of them would require images as an input. So for such cases here, now we have images. We are able to encode our time series data into images. Then of course we have imbalance in our data. Let's look at how we deal with the imbalance, but let's plot our data across classes, maybe on a pie chart, to see what they look like. Then we now know how to deal with our imbalances. Yeah, I found how we import the class weight. So what the class weight does is it helps us to balance the number of images across all classes that it is passing to the model during training across all epochs, so that it doesn't see more than one set. It doesn't it doesn't train impartially, so that it doesn't see majority of one class and sees less of other classes. So it tries to like balance them and see the ratio between each classes and knows how it fits that to it. But it's still not the only way to address class imbalance. There are things like smooth techniques. There are other things you could possibly do to like to downsample, upsample, pad your data, and there are a couple other things like maybe use another evaluation metric beyond accuracy, because where I have data imbalance, I'll think of what my primary aim is. Am I looking for more am I favoring more false positives or more false negatives? I'll consider other metrics like the harmonic mean, which is the F1 score, or I use say the precision or the record. Precision is good for if I'm favoring true positives, false positives. The other one for more false negatives. False positive is like a situation whereby you are sick, you go to a doctor, and the doctor tells you you have a certain sort of sickness, and meanwhile that's not what you have. You don't have it, you are not sick. Or maybe you just visit a doctor randomly and doctor tells you, oh, you are sick, you have a certain illness, and meanwhile you don't have it. It was a false diagnosis, so that's false positive. They told you you had it but you don't have it. False negative will be the reverse, where you don't have it but they tell you you have it. So sometimes, depending on the scenario, sometimes it's better to be on false positives. It's better you tell me that I have it and I mitigate it than to tell me I don't have it when I have it and it's killing. But depending on the situation, this is finance, it's about money, so it's also important to look at which one outweighs which one based on the context, and sometimes you might just consider the harmonic mean. But let's carry on. So what we want to do is to compute the class weights. I'll do that by defining a variable train 1d and do this np argue max here. Then class weights is going to compute all this. Brilliant. Print the class weights. It's count up to 8. The next thing we want to do here is to train our CNN model. So I think it's a milestone. Let me put that here. CNN model. So I'll just train it functionally inside the function. So I'll call it train CNN. And I want to pass in my train data. I want to pass in my validation data. I want to pass it my class names. I want to pass it my class weights. No, class weight dictionary, that's this one. I suggest the model should be used. Let's take it, there's no harm in trying. If you suggest this model, let's take it, there's no harm in trying. I don't think I want history, so I can just say model is equals to train this, and then plus marks, because it's a multi-class classification problem. It's not binary, it's not 0 or 1, yes or no. It is across 8 classes or 9 classes we want our predictions to come from. Then okay, let me say I return history. I'm only returning history so that I can call it when I want to make the plot for the plot that tells me how well my model performs. But I'm surprised why is train data. Let me see what it was called here when we did the and voila, we're good. So if I come back here and I do this, it would run, but not so fast. I also want to prepare a plot that tells me if my model is overfitting or not. So I want to prepare a plot of accuracy per epoch, loss per epochs. So I think I found the problem. It was from the class weight. We allowed the computer to suggest something for the class weight here. So I think how we computed class weight dictionary was not really good. Then I corrected it some ways. You can check the class weight docs if you really need to understand this very well, but it just gives implementation on how to use it basically if you ever get confused. But I think it's from the class where the problem is coming from. So I run this again, then I see it on my model. It should work now. Hey, still not working. Class weight dict. Class weight. Oh, okay, I'm calling the wrong thing. Oh, there's no S here. Oh, damn. Okay, let's see. Hopefully it works now. Has no attribute keys. Where's this error coming out from? Right. No attribute keys. Oh, I think I know where it is coming from now. Thanks to chat. It has explained it. So I think here I'm not passing the class weight dictionary. Oh, finally training our neural network. Good. I'll leave this. It's just going to be simple. I'm not looking for the best I'm not looking for the best metrics right now. It could be overfitting and it might not be. I'm not looking for the best metrics right now. I'm just trying to implement the algorithmic trading model. I'll make separate videos where we optimize to get the best metrics and best performances. So here, for training and evaluation, we see this. Okay, not too bad. This came down. This is the normally this is really no. Okay, this is what I need. Validation loss and training loss on the loss per epoch plot. We want our validation loss to reduce as our training loss is reducing. We don't want it to cross over it. So from this point here, it starts to overfit. But if there was a steady reduction between two of them and they were moving at the same pace and the orange one was still below the blue one, it would be all right. It's overfitting for now, but I'll leave it that way and just go straight on to the next thing. So the next thing I want to do is do I have the model saved somewhere? Yeah. I didn't do model checkpoint, but I should have done model checkpoint and added that to this. Model checkpoint allows us to save the model. So I don't have model checkpoint here, but I think I did model.save. Did I? Oh damn, I didn't do that. So maybe I could quickly add the model checkpoint. One sec. I'll quickly add the model checkpoint and I'll add our early stopping. Or there'll be no need for early stopping, but I'll add the model checkpoint. So here's what I would do. So this is our model summary. We're not going to. Oh, this looks better. This looks like a better. This doesn't overfit. And yeah, it doesn't overfit. Let's do something interesting before we leave this at this. Let's test our. Let's run our test data. We've not used our test data, so let's call something. Let's say How do I loop that through? Okay, let me loop it through into the function then. Inside this function, I would make it show right after the summary, show me my test performance. Let's call this true classes. True classes is equals to give me an empty array. Pom. Predicted classes. Give me another empty array. Pom. And I say for image batches. Thank you, AI, but sometimes it can be confusing. I'll call this batch predictions. Batch predictions is equals to, so that's it's batched. I say batch predicted classes. True classes. Extend batch true. Batch true classes. Okay, let's do this. Copy the argmax here, labels. Don't want to do the numpy here. Take it out, record MP. Alrighty. Batch true classes. Batch true classes. Let's see. Predicted classes. Dot extend batch predicted classes. Then I want to print a classification report. Print classification report. Then from sklearn, give me classification report. Oh, I already have this. Control Z, then go back here. I'm liking AI suggestion for me. Okay, say I take this, but I already have that. But just take this out. I think the confusion matrix for now, just to see how the model performs. But the aim of this project is to develop an algorithmic trading system, and not exactly to. It looks like I don't have sklearn classification reports imported. Yeah, algorithmic trading system, and not exactly so much on the logic. I'll make another one that concentrates on the logic, but this is just the end-to-end pipeline of what goes on in the algorithmic trading model and the kind of level of thinking that goes on. So I'll run this again, then I'll come here and do this, so we should be able to see performance and how it performs on test data. So it's going to take some of the test data as instances, and it would make predictions on them. These losses are quite heavy. I hope this doesn't overfit again. Looks like it's really going to. So overfit. Okay, it won't overfit. It won't overfit. Accuracy improved a little bit. So we're not looking at validation accuracy, we're looking at loss per epoch. But yeah, validation accuracy too can tell us if it was still learning more, there's still potential to continue learning or something. Well, loss per epoch, oh, not too great, but also not overfitting. Maybe it might be underfitting, but yeah, not too bad. And then let's see what classification report looks like. Well, the classification report is showing an error. True classes, predicted classes, then target names is equals to class names. I wouldn't worry too much about that for now. I mean, I'll just leave it. I have my model saved, and that's priorities for me, and I can always use the saved model. And then yes, I'll just take this out. Let's look at it. I'm going to \n here. If \n, classes, predicted classes, target names, class names, return model. So where did you get this error from? Error came from mobile of classes 8 does not match target name. Try to does. Okay. I mean, I'll just take out the entire classification report of the thing here, and yeah, just print out my true versus predicted values for me. Did that come out? Yeah, it came out. True versus predicted values actually came out. Open it in the text editor. This is what we want to see. No, this is for classification report. I expect to see true versus predicted also come out. But this for classification report, I should see. let's run this again. But I'll make more detailed videos about performance and optimization. This video is already long enough. I just want us to get to our live trade execution, and yeah, see that it actually works. Text editor. Okay, this doesn't show. I wanted it to show the performance. It's okay, not too bad. It looks like there's still more stuff here. Let me do scrollable elements then. But this is all there is to scroll. Okay. Of the historical data and is true. Yeah, one sec. Oh my god, I'm just realizing that when I stopped to pick my call and came back, I didn't play the video, so I'll just go over what had happened. So yeah, I did my import statement. I don't know what point I stopped recording from, but I did my import statement. Then yeah, I'm mapping each pattern to a signal. So I have 3 signals: long, short, and flat. So I'm mapping each pattern. Bearish, it means it's going down, we're going short, you only sell from there. Bullish means we're going long, we're going up, you buy from there. So I'm mapping each of them to the pattern. So when the model gives any of these outputs, we map them to a pattern, to a signal. Then the signal is what is then passed to the API that executes the trade. So here's still part of instrumenting the API on this side. So I use my IB wrapper first, and yeah, normal create the E wrapper, then historical data, and next valid ID, because I want to be changing the order ID for each order. Let me know it's a new order every time I see it in my output. So I've not gone too far. Then this is where I am next. Let's take it from here. Then AI is helping with its suggestions. So give definite each client self the wrapper here, historical data, request latest data, and I'll call this latest. Request latest data, and then here I'd say define, no, let's do this. Define create contract as usual, And next thing I want to say is my contract. So I have some of these scripts up, so I would understand if AI is able to suggest some of them, like this and this, create contracts, and some of the request historical data and all that. So I understand if AI is learning and adapting it to this phase that I am, that's time to execute. So I'm not too surprised. And plus the docs are publicly available, so I don't expect AI to understand it. And since it's GitHub's Copilot, I'm sure a lot of people have done projects, and there's lots of code for it to learn from. And yeah, then here, def detect candlestick patterns, so that when we pass in OHLC data, that's open, high, low, and close volume data, because that's what the API will get, it converts that, it detects pattern, then it also converts it to a Gramian Angular Field image, and takes the model takes the form of data it can take. OHLC current previous previous high, previous low, previous close equals to previous. Nice. Then let's see if my close is greater than my open and my okay, what's my previous low and it is greater than, yeah, this seems correct. If this returns user button, okay, these codes are up there, so to just keep giving me. Else if return user top, else if return PSN line, else if return shooting star, else if return bullish and golf, else if return hammer, else if return. Looks good. This point here, I want to if C minus L is greater than 2 times H minus C return hanging man. I lift this L minus C return bearish and golfing nice actually, else return my hammer or return no pattern. I want to put this here. No, here. This should be here. This should be here. So we take us to if, then the return should be here. This return should be here. The return should be here. Then it looks about right. And then for my next cell, I want to do the image conversion now. The sequential numbers to image conversion. Convert to graph image. Data underscore row. CS equals to np the array into data row open. Oh nice. Graph is equals to Gramian Angular Fields. Image size of length of TS and then of TS. image, cafe transform, image, numpy expand the dimensions, image, and the axis should be 2. Axis should be 2. No, it should be -1 actually. Then let's np the repeat image 3 here and convert it to RGB here. Return image. Then here we now come to our trade execution. After all the pre-processing, execution, then define execute trade here. I want signal, I want wrapper, I want action, so I'd rather say signal, wrapper, client, contract, quantity. No trade signal, skipping execution. Not a bad message. Good message. If wrapper, the next other ID is non-print, no value there, just so that we can track it. Then I'll just go straight to the actions. Action buy if signal is equals to longs, else sell. Order is equals to, let me say order ID. Let's take my call. I'm getting this error. Oh, we're supposed to create order. Didn't I create this function? Oh, I didn't. So it should have been after contract. So let's quickly create it. Define create order here. So that will take order ID, action, quantity. The double contract. Actual quantity here. Order type will be market order. That's the instance one. Order ID, action here. Total quantity here. Order type here. And let's do trade only. Okay, so this is good. Oh my god, I have gone far and long. Thought I was doing all this. Yeah, then so this would take current data here. Then open current data high, current data low, current data close. Great. Then it does the same thing for previous data to open high, low, and close as well. Then yeah. I'm going to our graph images. We'll transform our graph images. Convert to graph image, current data, graph image is equals to let me use the TensorFlow one there. tf.image dot resize. That one resize it actually. I don't want to resize it, let me just leave it. Let me use tf.expand. tf.expand dimensions here. Oh, I think the model I did it takes 32 by 32, so let me just convert the image to that. I can see graph image resized. Then call this again graph image resized as well, equals to that. This is graph image resized. Then graph image resized again, graph image resized again. Then you don't know, but I'll just divide by 255, so that was 0.001. 255.0, same thing. Yeah, then we say prediction model. Prediction is equals to model to predict graph image resized. Yeah. Then predicted class is equals to no, I want class names. Yeah, predicted class. So I'll take this out. I'll call this predicted class. I'll put the argmax. I'll put this in parentheses. Just outside it, I'll say np.argmax if predicted class. That's my battery. If predicted class is double equals to no pattern. There is no pattern. No. And pattern is equals to no pattern. Signal is flat. Else signal is equals to pattern to signal dot get here prediction class flat. Then here I want to print the signal. So let's say for this, call the signal. Print a confirmation for me. Print waiting for next candle. Put that in like this, and the strings. Then what else would I think of? Time the sleep. Let's do this at 10. So this still in the try block. Let's go to the except block. Except keyboard interrupt. Print stopping strategy loop. That's if I interrupt it from the keyboard or from the console. Client dot disconnect. Yeah, so that's it. That's it. Then I can run it in the same cell too. So if I just say start trading loop, it takes this quantity is equals to 1. So if I run this cell, yeah, it would start executing a trade for me. Before I run it, let me go and look at my interactive brokers platform. No trades on orders, nothing in summary, nothing in orders, nothing in trades. Please remember, this is paper trading, not real money. It's just for the learning process. The core here is we're teaching algorithmic trading. What was this? What was the CL greater than equals to 2 somewhere here? It's inside here. It's inside here. Where did you print line 140? How do I find line 140 now? CL, if CL is greater than, just copy it and do a Control F, Control V. Show me where it is in my code. This is 1. What's the second place? 2. Should take me back to 1 again. 1 here. Oh, I saw it now. I saw it. How do I get back there again? Take me back to 1 here. This is it. Let me start this. Yeah, so it looks good. Let's run it again. Yeah, looks good. Create contract. Where am I seeing this? Client or create contract inside my trading. Okay. Client that contract equals to client or create contract symbol. Okay, let's go inside the trading. Okay, I think it is this place. Client dot, it should just be create contract. Then that's the function we have. Then here I'm thinking this should have been start trading loop, not trading loop. Start trading loop. Then what did I pass here? Start. That's why it worked. Trading loop. Then here let's hope it works now. I see. Okay, so what we need to do is we need to copy all the dependencies. We would need to turn it off and turn it on again, but it would require all the dependencies. So this one would not be loaded if I do that. So let me copy this and just add it to this import here, so that when I shut down the kernel to restart it, it will work. But yeah, I'm still spotting that release my control F. I'm still seeing some inconsistencies. Create other. What was the name of the function for distribute? Let me just copy it. Next to me, there is some order ID, contract, and order. What does it take in? Order ID, contract, and order. Where was it just now? Oh, this should be action, not contract. Order ID, action, and quantity. Order ID, action, and quantity. What did I give you? Order ID, action, quantity. Order ID, action, and quantity. Yeah, that's what it should be. Create order, I'll take in order ID, action, and quantity. Let's see if we should restart the kernel and then run our imports and then do this now. TF is not defined. Oh no, we have to go back to TensorFlow and define all this. From imports TensorFlow as TF. Import numpy from TensorFlow and numpy. Those are the main dependencies here. Start kernel, import them again. Takes a while. Model is equals to IB client is equals to IB wrapper. Oh god, I have to go back up to where I called it. Okay, let's go. We'll do everything from here up until fetching the data. So I'll do everything from here up. And when that is done, I would come back here and run this again. Request latest data. Where's that one coming from? You should take prediction instead of predicted class. Start this again. Minor fixes, but it looks like we're heading in the right direction. After that, then we'll do this, and hopefully this be the last fix. Finally, our algorithmic trading model is working. It's a 1 minute time frame data, so every 1 minute it gets new data and we load. So it took a long position based on what the model is telling it, and let's go and look at that on our trading interface. Here we can say it's supposed to give us what it is trading. To be able to see summary orders, it's a place we can see it. Okay, let's go to find there. How do I usually see this thing? Oh my god, my phone is ringing again. 1 sec. Sorry, I'm back. I'm trying to find there's a place I could see the breakdown for the trades taken so far. Is it activity? Is it orders? Let's do Control R. I should be able to see it. Let's look at the API again. It has taken more trades. It looks like it's going long on 1 minute candles. Maybe gold seems to be buying. Yeah, but there's a way to see my portfolio. Okay, yeah, I think this is it. Activity statement, export activity portfolio analyst. Could it be activity statement? No, I don't think so. Something went wrong. We'll try to process here. I don't think that is it. I think it could be trades. There's a way to check it. It's not FYI. It is a new window. No, it's not. There's a way to check the IBKR thing when we're on a trade. Let's go to account statement. that it? No, it's not outside of this. This thing has a complicated interface, so sometimes it is nice not here. It's supposed to come up where I see my API connections. I promise it always comes up automatically. I don't know why. I have to look for it now. Create paper trading account. This is the account we have, so I urge you guys to please see that you're creating a paper trading account and not a live account. Then I'm trying to find what's it called? Bring this closer. My battery is low, but looks like we've been seeing more long positions in the last 1, 2, 3, 4, 5. In the last 5 minutes, it's very short, it's still long. I want to see a breakdown. There's a way to see it. Down. How do we do this? There's a way to see it here. See here. Okay, here is all configure. Live orders, no, completed orders, all orders. There's a way to see my summary and my trades, others, summary. I take out my summary from here. I think so. This is not it. What's going on? This is not it. Detach tab. There's a way to see it. Oh my god. How do I even close the trade if I'm not able to see it? It's here. Okay, I'm trying to close the trade and see. Close all positions. 100%. Cancel. There's a way to see it. So we're going long on gold. Chat. How do I see my trade summary on IBKR TWS application? I do the trade summary. But then look at the activity panel at the bottom of the interface. Click on the trade summary tab within the activity panel, provide the content summary. Okay, so that's I think what I've done. Activity. Other hidden plugins. No. So what could it have been? Okay, here's what I'll do. I'd stop it, I'd interrupt it, and and I'll close the TWS app and I'll run it and I'll start it again. Yeah, I want to exit. It's been open for too long. Oh, there. Looks good. So let's run our code again. Because of the client connection through the socket ports, we need to restart. I will tell you run everything from here below. It's just 2 cells really. Then here, let's see what happens here. So that's my trade. This is not showing. I think I know. Interrupt it, restart it. Let's go again. So for my longs, it is buying trades here. Trade history, yes, it's in there. Why is it not showing the API, the ones that are done over the API? Well, it usually works, but I don't know what's wrong with the IBKR API that it's not working here. But trust me, it does usually work, and those are the trades we see here. In a paper that I have that is currently being published, it worked, and yeah, I want to see what it looks like. So he gives us things like this, where we can see the quantity that was taken from the trade summary overall. Then we see all the trades that were taken, and if you see it's the same date, the trade was on at a certain time, from this time up until this time, from about 9 till 5. Then at different times, when it thinks it's good to take a trade, it takes trade and follow the direction. When it thinks it doesn't take a trade, it stays flat. So this is the entire workflow, but I don't know why my trader workstation is not showing the trade summary, but I'll look into that and put it in another video. Yeah, but that is it for now, and that'll be the end of this video. Thank you.